Good morning, everyone. So, in this third lecture, what we are going to see is an online ARM assembly language programming simulator. So, come to Google and then type ARM V7 simulator. This first one, what we are seeing is the online simulator we are going to use today for simulating the ARM assembly language programming. So, open it. So, this is the online simulator tool. So I am just going to give a brief overview about the different windows in this. This is the first window, the editor window, where we are going to type the corresponding assembly language program. The language we need to, depending on the language, whether it's assembly or C, you need to choose. So we are going to see ARM v7. The second window corresponds to the disassembly window. After compiling and loading, automatically the execution will come to the disassembly window. And this is the memory window where you can enter the data in the memory. Now if you come to the leftmost windows, these are the different registers. So R0 up to R12 we have, along with stack pointer, linked register and program counter. Then we have the CPSR, current program status register, where the different flags are also given. So the main flags for programming purposes we are going to use is negative flag corresponding to N, 0 flag corresponding to 0, carry flag corresponding to C, and overflow flag corresponding to V. And here you have the settings window where the memory format, whether you want to display the contents of the memory in Word or Word format or half word or byte format, that also you could select here. If you choose byte, every location will be shown in byte format. If you use a half word, it will be shown as 2 bytes. So this 4 digits corresponds to 2 bytes. Every digit corresponds to 4 bits. So we have 4 digits that corresponds to 16 bits. So this will correspond to 2 bytes of memory. The memory location is 0, 0, 8 zeros and 6, 7 zeros and 1. Those are the 2 adjacent memory locations. So you could choose either in byte format or word or half word format, and you could take the format in hexadecimal or so on and so forth. So these are the main settings window. Now come to the editor window. Whatever program we started with in the last lecture, I am just going to type it and then show it to you. So I have typed in the assembly language program corresponding to the load instruction what we saw in the previous second lecture. So this is the corresponding assembly language program. Now once you enter key in the program, you need to give compile and load. So if there are no errors, the compile will give compile succeeded. If there is an error, it will give an instruction. It will give the corresponding instruction, corresponding message. So if you see in line number 4, bad arguments to instruction LDR R0 equals. So I missed a comma, so that might be the error. Now I am correcting it. So it's the compile is succeeded. Then once the compile is succeeded, automatically the corresponding window that will be loaded will be the disassembly window, where the corresponding to each instruction the disassembly code will be shown. So if you see here, the first instruction was LDR R0 equals this one. So that instruction is disassembled as this 1 followed by 7 zeros corresponds to the hexadecimal number. The equivalent decimal number is this. So R0 will be moved with the value of this decimal number. That is the meaning. Then rest of the instructions are plain simple load instructions. So it is also shown. Now before executing line by line, let us go to the memory and enter the data. So the memory where we are entering the data is 1 followed by 7 zeros, as we have seen in the last lecture. So come to this corresponding tab and enter the memory where we are going to enter the data. So the memory address was 1 followed by 7 zeros, 3, 4, 5, 6, 7. Then click enter. When you click enter, you will get this corresponding address. Since I have chosen here as byte format, it is in byte. Then you can choose either in word or half word format and enter the data. It's up to you. But after entering, you can double click and enter the data. After entering, you need to press enter key, then only the data will be saved. So here it is, the first one was 12, then 34, then 56, enter, 78. If you don't press enter, it won't be saved. So here I didn't press enter, so it was not saved. So 78 and enter key. So 1, 2, 3, 4, 5, 6, 7, 8, like we have shown in the last lecture, that is the number what we entered. Instead of entering it in a byte format, you could directly enter in word format also. So here the second number was A, B, C, D, E, F, F, F. So you could enter A, B, C, D, E, F, F, F and click on this one. Now if you see here, we entered like 1, 2, 3, 4, 5, 6, 7, 8 in byte format, but it's now showing as 78, 56, 34 and 12. The reason being the memory format that is being followed here is little endian. In little endian format, the lower byte corresponds to the lower address. So the lower byte of a word will be saved in the lowest address of the corresponding 4-byte memory location. So if you give byte here, you can see that clearly. This 12, this is the lowest byte that comes in 1 followed by 7 zeros. Then the next byte from the lowest position is 34. It comes in 1 followed by 6 zeros and 1, and so on and so forth. And the most significant byte is 78, which comes in 1 followed by 6 zeros and 3. Now for the other case, when we entered, so it came like the FF, EF, CD, AB. So we need to read from the lowest location. So if you see here, when we entered, the first one was in byte format, then we entered A, B, C, D, E, F, 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 where AB became the MSB. But if you see our data, when we entered, FF was the MSB. So FF, EF, CD, AB, that was the data we wanted to enter. So let me just once again correct it. So here I entered A, B, C, D, E, F, F, F. So you need to understand what is the actual number. That actual number is in the correct order you need to enter. So the actual number which I have shown in the previous lecture, it was FF, EF, CD, AB. From the bottom to the top you need to read, because we followed little endian format. So here I had to enter FF, EF, CD, AB. Now if you go and see in byte format, you will get the corresponding thing correctly, like in the previous lecture, second lecture, what we have shown the corresponding number A, B, C, D, E, F, F, F. So now the data is entered. Now come to the disassembly window. Automatically in the first line, this line is going to be executed. That line corresponds to the first line of the editor window, where R0, this register R0 is going to be loaded with 1 followed by 7 zeros. You could run the the corresponding lines of the program in any of the windows. Okay, so we are going to execute line by line. If you want to execute all the program together, we'll press F3. If you want to execute line by line, we'll press F2. So I'm going to press F2 to execute line by line and show you the different values which we have already seen in the last lecture. So I'm coming to the disassembly window to see which line is getting executed. In the disassembly window only we can see which line of the program is currently being executed. So this is the first line which corresponds to this one, where R0 is going to be loaded. So I am pressing this F2. So this line is executed. R0 is loaded with 1 followed by 7 zeros. In the second line, R1 is going to be loaded with the value pointed by R0, which is going to be 4 bytes or 32 bits, because it is LDR. So the 4 byte that is going to come is from this location 1, 2, 3, 4, 5, 6, 7, 8. That is the value in the format 78, 56, 34, 12. That is the number which is going to be loaded. So let us see whether it is getting loaded. So 78, 56, 34, 12. From the memory location, 1 followed by 7 zeros is being loaded with the most significant byte as 78 and the lowest significant byte as 12. Now let us see the next one, LDRB, R1 comma bracket R0. R0 there is no change. So 1 byte is going to be loaded from the memory. Which byte? 12. 12 is going to be loaded into R1. See, 12 came to R1, the lowest byte. Now this is half word. So we are going to get 3412 like we have seen in the last lecture. So let us see that. So 3412 comes. Now here again from the byte from pointed by R0, this location will be loaded to R1, then R0 will get incremented by 1. R0 should become 1 followed by 6 zeros and 1. So let us see that. So in the memory, the first byte again is 12. So that alone will be loaded. So 12 will be loaded. R0 got incremented by 1. Now here if you see from R0 plus 1, from that location R1 will be loaded, but there is no change in the previous R0. So R0 will remain the same, but from 1 followed by 6 zeros and 2, the value will be loaded. What is the value in 1 followed by 6 zeros and 2? 56. So 56 will be loaded in R1 followed by the R0 remaining the same. So 56 is loaded, R0 remaining the same. Now here R0 again 56 will be loaded from this 1 followed by 6 zeros and 2, but R0 will get returned back with 1 6 zeros and 2. That is the like we have seen in the last lecture. So if you see 56 was again loaded, but R0 got incremented returned back with the value 1 followed by 6 zeros and 2. Now this is a half word. For from 1 6 zeros and 2, a half word is going to be so this is LDR R1 comma bracket R0. Now this will if you see, this will give a memory misalignment error, because this address we need to see whether it's divisible by 4. So you press F2. See, memory read of 4 bytes at address 1 6 zeros and 2 is misaligned. Okay, so this instruction doesn't work, because the address when we are loading a word data from memory should be divisible by 4. So I need to correct it. So I am going to delete that line, corresponding line, whether that error occurred. It was line number 8, LDRB, the corresponding line LDR R1 comma bracket R0. So that one I have to, line number 11, that I have to delete. So let me delete this. And let us compile and load once again. Let us go line by line. So I am not going to explain up to that point. So here now R0 is 1 followed by 6 zeros and 2. Now this is a half word which will be taken from the location R0. After that R0 will get incremented by 2. So it will be taken from the location 1 followed by 6 zeros and 2 and 3. So what are the values in 2 and 3? 56 and 78. So it will be saved as 78 56 into R1. So that is saved. After that R0 became incremented by 2. Now here we are going to take a word of data from this location, the 4 bytes of data from starting from that location. So what is a 4 byte of data that is going to come? So it is FFEFCDAB. So that is going to be loaded to R1. Then after that R0 will get incremented by 4. So R0 will become 1 followed by 6 zeros and 8. So let us see that. You could press either F2 or click this one. So it becomes 1 6 zeros and 8 FFEFCDAB from the memory, that is saved into this FFEFCDAB into R1. Now R0 is 1 followed by 6 zeros and 8. So here what it will do, again 1 followed by 6 zeros and 8, the corresponding value, the word will be loaded into R1, which is A, and R0 will get incremented by 4. It becomes 1, R0 becomes 1 6 zeros and C. So let us see that. So A, it became 1 6 zeros and C. Now here if you see, R0 will be first incremented by 4. So 1 6 zeros and C, when it gets incremented by 4, it becomes 1 5 zeros and 1 0. From that location, which is 1 5 zeros and 1 0, this one, this A, from the bottom to top, since it is little endian, A, it will be loaded to corresponding R1, and then it will be returned back with that same value 1 5 zeros and 1 0. So you do that same value. By default, all the memory location will be showing as A. That is why we are not seeing a change in value, because we haven't entered any value in these locations. So it is A, all 8 A's, and R0 became 1 5 zeros and 1 0. Now all these instructions what we did, this is applicable for store also. So this is how we do the assembly language, a basic assembly language program in using this simulator. Now one more thing you could do is, instead of going to the memory and then loading the value from the memory, directly you could edit any of the corresponding registers in this window. So here you could change 87654321, click on enter. That register becomes the corresponding value. Then you could simulate any instruction of your choice to understand what happens when you are having that value. So no need to go to memory and then enter the value, then load from the memory. Directly here you can double click and change the value in a register of your choice, and then you can play around with the different instructions. So this is how you'll start with the programming. We will see more examples in the subsequent lectures. Thank you.